Okay, so question 7 and 2 from Statistical Rethinking, second edition. So we want to explain the difference between model selection and model comparison, and then describe what information is lost under model selection compared to model comparison. Okay, so let's kind of get our bearings here. So both of these ideas, model selection and model comparison, are using information criteria or Pareto smooth importance sampling or cross-validation to rank the models, okay? And specifically to rank these models according to what we expect, how well we expect those models to predict new data, all right? Just to kind of put some, to make some of this stuff a little bit more concrete. So in the Rethinking package, there is a command called compare, and then we can compare different models, right? So these models might differ by the explanatory variables that they have, or the priors, or something, but they're different models, okay? And in this case, the compare function is being used with PSIS, all right? And then we would get the different PSIS scores for these different models, all right? And so with model selection, what we would do with these different values is we would just use the best score, right? We would just use, in this case, model M51, all right? But in model comparison, we would use, well, we would use every model separately, individually, all right? There is also a third idea that is not really expanded on in this volume of the book, but the first edition of Statistical Rethinking talks about it a little bit more. It's called model ensembling, where we take these, the predictions of the several models and then combine them into kind of an ensemble prediction, right? And so the amount of weight that each model receives, or the prediction of each model receives, is based on the ranking of these scores. So for instance, so here's our three models. According to the PSIS in this case, we can assign them different amounts of weight. Okay, so in this case, model M5.1, in our combined prediction from all of these models, the predictions from M5.1 would receive 75% of the weight. M53 would receive 29% of the weight, and the last model would receive none of the weight. Okay, all right. So, when we are making predictions, right? If we're using our models just to make predictions, we're really forced to either use model selection, okay, using the best model, or ensemble, right? Using ensemble predictions, right? Obviously, because if we need to make one prediction, we have to have one method by which to arrive at that one prediction. Okay, and this should make sense in the prediction context, because WAIC, PSIS, cross-validation, one way that we can think about these things is that they are ways to tell us how well our model is expected to be able to predict previously unobserved cases. Okay, but what these things do not do is they do not tell us about the causal validity of our models. All right, that's something completely different, right? Prediction is very different than making causal inferences. All right, so in other words, if what we are interested in is causal inference, we are not directly using these scores to tell us which model is causally valid and which one is not, or something along those lines. Okay, so if we're interested in causal inference, what we want to do is we want to discuss all of the models, right? With prediction, we would just use one model or an ensemble. But if we are comparing models, trying to make inferences, we would think about all of these models in isolation. Okay. So then you might ask, well, then why even use these different metrics, WAC, PSIS, cross-validation, if what we're interested in is not prediction, but causal inference? Okay. Well, with causal inference, so say that we have three models here, and let's say that they, as far as we understand the system that we're studying, they all have valid claims, or they all have similar claims on their validity, on what we think that, as far as we're concerned, they could all represent the system that we're studying, right? Well, now these different metrics, now they can tell us things like, oh, well, M53 seems to be overfitting the data a little bit, which means that something about that model, maybe it has predictor variables that are not included in M51. Maybe that explanatory variable or those explanatory variables are not generally important to this system, right? So we can systematically test through different models variables that may or may not be causing overfitting, and therefore may or may not be generalized into the system as a whole, for instance, right? So when we are, if we are interested in causal inference, by using model selection, we are discarding all sorts of information about particulars of these models that may or may not lead to better or worse PSIS scores, which again can be used as something as an analog to how generalizable the assumptions of any particular model are to the system as a whole. Okay, so anyway, I think that is it for this one.